Hi, welcome to class 3 for R for lab data. Today we're going to be looking at ggplot for data visualization. So first off, before we start anything, we are going to talk how to install packages onto your R programming system. So today we're going to be actually working with tidyverse, which is this program right here, which is a package system that includes ggplot. And if you want to install it on RStudio, you can go over here to the Packages tab, press Install, and then you type out the package you want. We want tidyverse. And then you hit Install. And I'm not going to do this because I already installed it recently. But you just install it and it installs. Or if you want to actually use a function to install packages, what you do is that you use the install function right here, which is install.packages parentheses what and the name of the package you want. And packages are just various programs and tools you can use to do things in R, like mid and max and things like that. It's just a package of various functions. Think of it like that, a package of various tools. And a tool we're going to be using today is ggplot. ggplot is a data visualization tool that is layered in various ways, and this layering allows it to be used for customization of visualization of data, and is very good. In the actual website, there's a very good tutorial right here, which a lot of this class is based off of. So if you want to read instead of listen to me, or you want to read more up on this, there's this Tidyverse has this wonderful website about how to use ggplot in various ways. All right. And they actually have like a very elegant way of saying how great ggplot is here. I'm not going to read it out, but you can read it if you want. So before you use any package, you actually need to install not install it, but bring it into your local R instance. And the way that you do that is that you run library, the function library, and then the name of the package you want to actually use. I'm going to run that, Control Enter, run that. It is now usable. So very quickly, I'm going to actually run ggplot right now, this graph right here, and then I'll explain what it does once we have a visualization of it. Okay, over here, you can see there is a plot tab, and it shows the plot we just made. And it actually saves all the plots that you will make until you clear it. And the way you clear it is actually using this little broom right here. I'll hit that broom, and it's gone. Let's make it again really quick. And you can see here that it has made a plot, and I'm going to go through step by step of how this plot was made with this little code right there. So first off, you call upon ggplot, the function, and then you put in your data. This is inbuilt example data in ggplot, which is miles per gallon. And then you use the function inside ggplot AES. AES is there to aesthetically assign, what AES stands for aesthetic, to assign what goes where. So the first value here, display, is actually the x-axis right here, so you can see. And then the next value is highway, which is the y-axis. And then color is actually assigned to class. And you can see here, the color of the dots is based on what class they are. And finally, you have a plus sign, and then what type of plot you actually want. So all this stuff would actually produce nothing by itself, but as soon as you add this plus sign and then on this geopoint function, the ggplot realizes that you want to make a point graph and then creates this point graph. All right, let's move on. So even though the example data is great, because it allows you to run examples no matter what, even if you don't have an Excel sheet to run it with. Um, it's not very useful in a practical sense. You have to get used to actually running your own data when doing this. So for most of this tutorial, I'm going to be using our data from my computer. So I actually exported the miles per gallon data into a CSV file so I could re-import it back into uh, the R instance so we could use data from my computer. So like so we're going to start working with that data now. And like always, when you're working with data from your computer, you need to make sure you set the working directory with this function, and then the destination of what folder that data is in. Go run that, and then we're going to then import that data with the function read.csv, and then the name of the file that you want to run it, and what you want to take out, and assign it to a value. We're going to assign it to the df object. Run that. And then we're going to run basically the same program we ran up here, just with data from our own computer. And it's exactly the same because we're working with the same data and the same like visualization code. But something I want to point out here is that, like I said before, the ggplot will actually store RStudio will actually store all of the figures you created, and then you can actually use these arrows here to navigate back and forth between them. These are exactly the same, so it doesn't look like I'm actually doing anything. Before continuing forward, let's talk about the cheat sheet. So ggplot actually has this wonderful cheat sheet. It's right here. You click on it, and it takes you to it. Well, no, never mind. It's right here. And what the cheat sheet allows you to do is that you can basically look at figures inside the cheat sheet, find the one you want to use, like, oh, I want to make this one, and then it shows you how to make that figure in ggplot. And these will make way more sense after we're done with our class today. So let's actually get back to that class after I get a drink of water. Here's the link to the PDF file, by the way, for the cheat sheet. So creating the ggplot is actually done with layering, and there are 7 layers to a ggplot. The first layer is data, which is a foundation for every graphic ggplot you use data or constructing a plot. The second layer is mapping. Plot is a set of instructions on how parts of the data are mapped onto the aesthetic attributes of the geometric object. Then layers. They take the mapping data and display in something human can understand and then represents of the data. Then scales. The scales typically form pairs with aesthetic attributes of the plot and are represented of the plots by guides, like axes or legends. Facets. Separate, small, multiple, or different subsets of the data. Coordinates. Parts of the plot as interpreted of vision aesthetics. And then theme. It controls most of the visuals of the plot that are controlled by the data and is therefore important for the look and feel of the plot. So we're going to go through each one of these layer one by one. First off, in descending order. First off, we're going to look at the first layer, which is data. And data is actually pretty boring. We're going to first get our data from my computer. First, you set the working directory so you're pulling from the correct folder. And then we're going to get the data right there and assign it to df. And then let's actually look at the head of that data. And once again, we're working with the miles per gallon data set. And it has manufacturer, model, display, year, cylinder number, type of transmission, drive, city gas mileage, highway gas mileage, FL, which I actually don't know what that means, and then class of vehicle. And to actually get the data into ggplot, you just put ggplot open parentheses data equals, or you can just have like data as the first function. And you can see when we run that, the data is not visualized at all. It's just a blank slate. It's the blank figure, nothing there, not even color. So to bring more life to your figure, we're going to start to the next layer, which is mapping. So mapping defines which value represents the axis of the figure. This is done with the AES or aesthetic function inside the ggplot. So once again, we have ggplot, we have the data, and then we have mapping equal to aesthetic. X axis is assigned to city, Y axis is assigned to highway. And you actually don't need this mapping. Like up here, when we originally did this, it was just the ggplot just knew what to do based on what order things were in. But for ease of understanding, we're just assigning it here directly because you can't do that. So let's run this. And the mapping just maps like what the parameters of the figure should be. So you can see here, city has been assigned the x-axis. The y-axis has been assigned to highway, but the grid is still empty. It is a blank grid, no data inside at all. So to get actual data inside, we need to go to the next layer. And the next layer, confusingly, is called layering. And it's when it says layering, it's very literal, because what we're doing is we're taking what we just did, and we're just adding another thing to it. So we're literally layering something on. So what we're adding here is that we're adding the ggplot function. So add, and then this. Let me actually do something really quick. Make it a little more easy to understand. So we're adding, we have what we made before, is assigning the axis and the data. And then we're going to add gm_point, which is basically telling the ggplot that we want to make this data visualized as a scatter plot. And then we're going to be adding actually a line to it, which I'll explain once we have the visualization. And this is actually more like in my notes here, it explains it. But I just wanted to put this down here because it's easier to show the actual like adding onto each other. We're gonna run this. And there we go. And actually something visually interesting. So we went from a blank to a grid to now this. And all we added to get to here is we added these two objects to it, like literally added bit to it. The ggplot. Give me a second. I'm actually going to run this without that. And then again, so you can see when we didn't have this function here, it produced this graph. But with this function here, we get this line here. And what this function is gm smooth, and it's adding a trend line to the scatter plot. And it's basing the line to a formula, and you define the formula as y to x. So it's the most basic line formula of like match x to y to make the line. And then you tell it the method you want for the line to form, and lm means linear. And it also creates this nice like area of like around the let me do that. It shows like a nice little like area of like error around the line. So very cool. So once you add layering, you actually get a visualization of the data. Okay. So only data with the mapping on it, with the telling you what kind of figure you want, and then finally adding on this line function. So now we're going to look at class scales, add color representing of each class in the data. So we're going to actually do the same thing again, but we're going to, inside the aesthetic, we're going to be adding color, the color variable, and we're going to assign it to class. So let's run this. And you can see here that, one, we got rid of this, so there's no more line plot. But we have this scale color for this, whatever this function is called, and it adds color variability to the scatter plot. And when I was going through this, I was wondering, like, why can you not have like this with it too? And I ran that, and it looks like a mess. That's why you can't do it, because now it's like trying to make a line for each class. It does not like it. So let's actually go back through here. So we have the ggplot with the axis assigned like we just did. We have we assign, the new thing is actually assigning the color as class. So the color of the dots are going to be based on the class of the vehicle. And then once again, the point, the scatter plot function. And then we're going to add this scale to color function, which actually makes this happen. All right. Now let's move on to facets. So we're going to, let's run this as usual. So I have a visualization of how the show. So facets are this like splitting the data up based on various conditions. So once again, we're going to have a ggplot with the data and the axes of city and highway. Then we're going to make it a scatter plot, but then we're going to add this facet grid function, and it's going to actually break up the data into year and drive. So you can see here, now everything is split up into year over here, and also split into drive. So it's split up into 3 facets. And you can stop anytime you want. If you like, this is the figure you want, or this is the figure you want, you can stop. Like, this is the beauty of ggplot, you can like really mix and match things and make them how you want. I'm just showing each theme and how it works with the data we're working with. All right, now we're going to go into theme. Theme is, let's run it. Theme is just basically, how do you want the figure to look? So we have the ggplot function with the assigning the axes, and then the color, we want the points. Then we make the assign scatter plot, and we assign theme minimum. There's various themes you actually can use, but we're just going to use theme minimum. And then you specify how you want the figure to work actually in the theme plus here. So like right here, we're saying, okay, we want the legend position to be at the top, which it is. And then we're like, and then you can ask for the axis lines to be a certain width, which it is right here. And then you can assign what color you want the axis actually to be. So for the x-axis, for a particular, we want it to be blue. Now it's blue and no longer black. And once again, this is showing how powerful ggplot is actually at making custom figures. You can really like mess with most of it. So we're going to bring everything together right here. No, I just don't want, sorry. We want to bring everything together right here. So we're just going to be running everything together. Everything we just did. And it creates, look at this figure. It creates this nice looking figure. We have, of course, a scatter plot. And then we have the facets. So we have the axes are city and highway, still are. Then we have the GM point, which tells it to be a scatter plot with the aesthetic of the color being placed on the based on display, which you can see here it is. And then we have the GM smooth formula, which is just a line, which all of them have. And then you have the scale of like what the color should be. You can see there they are have a various scale. And then the facet grid, which is very obvious. It's they're all in facets based on year and drive. And then we're fixing the coordinates. So just making sure the coordinates actually fixed so they look proportional to each other. And then we're setting the theme as minimum. And then we're going to add a theme to the grid, and it's element black. So a very like light grid. So that's all of them together. And once again, here's the cheat sheet. So with that cheat sheet and all this information, you should be able to start doing visualizations, including, and if you want to read more up on this, there's great, the ggplot page has great examples on how to get started, and then like it shows you like how to do things, and it's really good. So if you want to learn more about ggplot, I recommend going to their site and just reading through like all the tutorial things. All right. Now that that is done, and we have time in this class, I actually want to talk about AI. I've been wanting to do this for each class, but each class has been going too long. But now that this one is done, I want to talk about AI. AI is a very useful tool. It's not too far off what people usually do when they have been programming, at least for me, because anytime I run into a problem in R or any other programming language, I just like Google what to do, like how to make a bar plot in R in ggplot. I'm just gonna run that, and then like this new A stuff is not what I'm talking about. But then like you can like find a page like somebody showing you an example of how to do the exact thing you asked for. So there's a lot of robust information out there about how to actually program. But now with AI tools, you can basically do the same thing. Like I'm gonna copy paste the exact same thing into here and then ask it. And it's gonna give me this wonderful little example. So this is very useful. It's a nice coding partner. The problem is one, the most effective way to use it is actually having some understanding of programming. So don't go gaveling away just forgetting everything I tell you. Actually knowing the language and knowing the various parts of programming can help you ask the right thing of these AI helpers to help you code. And a lot of this stuff that these AI give you, it's very short code. So if you want to make something more complex, which right now you don't really need to, but if you want to make something more complex, you need to ask it multiple different things and make like multiple little programs and then link them all together into one big program. And you can't really do that without understanding how programming works and like understand the thought process of how like one program can lead to another and how to like put them together. So ARs are very useful. Just understand that at the end of the day, one, You need to understand what the programming language is telling you. You need to understand like what it's telling you to do. You can't just copy and paste it because, especially in scientific work, because we need to understand how the math or the figures or anything works. We can't put anything in the black boxes and then believe what it gives us. Two, knowing the language of like how to ask it, and three, actually how to use it fully by giving it a bunch of little questions so you can answer a bigger question by building a larger program. All right. Yeah. And that is it for today. I shorter class than the last two, but it is still a lot to digest. So let's talk about the homework really quick, and then I'll give you back your time. So the homework is the load class example one onto an instance of R and create a figure that represents a column year, file, fly, and then highway in the data set, and then email me the results. And if you want to go beyond and before, like go beyond what this is, actually, after writing your own program, try to use the an AI system to make the same program and see how like the different what gives you different than what you actually made and see if it's actually better than what you made because you could use it as like a learning opportunity or to better understand like how these AIs actually work. All right, cool. Thank you for your time, and I will see you soon for the next class.